Good afternoon, everybody. This is Francis Nicholas, and this is my paper circuit challenge for my integrative STEM activity. So I'm a tech ed teacher. I thought I had an advantage and thought I would do a little research on creating series versus parallel circuits and how to make an activity for appropriate age students for this topic. As I started to do my research for this challenge, the standards that I found and decided to use when I wrote my lesson plan targeted fourth grade students. And as I worked through this activity, I tried to write my challenge that I would give to students for fourth grade students. Being a high school teacher, this was kind of difficult, but I wrote the challenge and thought it was good for them. As I worked through the challenge, I realized that not only would this be good for an introductory activity for fourth grade students, but I think we could adapt it to some more challenges and more calculations for older students. But that's where I started. So into my working through this activity. So step one was to create a sketch. So here are my two sketches. On the top, there's a sketch of what a parallel circuit would be drawn as. On the bottom is a series circuit. So the difference is all the positive and negative leads connect on a parallel circuit. In a series circuit, it goes from positive to negative, and then the negative connects to the following positive so that they're in a series. From the sketch, we go to laying out the circuit. So I use the copper tape and tape right on top of my sketch. And I thought this would be really good, especially for young students, because it would give them the opportunity to kind of see it develop from something they started with. So here's the series circuit. Here's the series circuit after I added the LEDs. If you take notice, the leads are connected, and I couldn't figure out why the LEDs weren't working. I was using two AA batteries, and I wasn't getting any of the LEDs to light up. So I tried to figure out what the problem was, and the problem had to do with the amount of current. So two AA batteries were not enough to light up all four LEDs at one time. I could light any one of the LEDs up if I put the leads right next to them, but it wasn't enough current to light up all. So I got a 9-volt battery, and if you notice, the lead had to move quite a bit because when I tested the 9-volt battery, I burned up the first LED. But if you look at the rest of the circuit, the three remaining LEDs all lit up. From there, my parallel circuit, so I removed one of the LEDs so that we were comparing apples to apples. And you can see all three LEDs are lit up with just the single battery pack with the AA batteries. From there, what we would do is we would test. So we could use the TI sensor. So I thought to control some variables, I taped the TI sensor to the top of a paper box. I would put the top one, and then I could make some readings, and it would work out just the amount of light that was being produced by the LEDs. Just from my naked eye, because my sensor battery died, so I didn't get any readings, but it looks like the lights are lit up fairly equally. However, it takes a 9-volt battery to light them up in series and just the two AA's to light it up in parallel. So I would hope that my students would see that it takes a lot more power to light the LEDs in a series configuration. I prompted this activity by the students are responsible to light an event center, and what of the two types of circuits would they choose to use had they been tasked with lighting up an event center, whether it be a stadium, an auditorium, some kind of large venue. How would they wire their lights to add that real world application? And the answer is pretty obvious. It would be a parallel circuit. So we use parallel circuits. We talked about the real life application would be an event center. They could create these prototypes with the copper tape and a paper circuit to simulate a real world activity or event. So that was my challenge. For other information, I will share the lesson plan, the challenge, as well as the how I rated this activity. Will all be shared with you. Thank you.